With Streamlit, it is easy to tie your application in with Azure OpenAI. Let's see just how easy it is. Welcome to this video on Streamlit. My name is Kevin Fiesel, and I am the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. The two prior episodes in this series have centered around building a reasonable-looking data application to review Chicago parking tickets data. We'll get back to that soon, but I'm going to take us on what may seem at first like a diversionary path. In this video, we are going to hook in a GPT-4 model from Azure OpenAI into our Streamlit app, and we'll do it in, maybe 75 or so lines of code. Along the way, we are going to learn more about session state, secrets management, and multi-page Streamlit apps. With that in mind, let's go back to the code. In this demo, what I'd like to do is integrate an Azure OpenAI GPT-4 model into our Streamlit app. To that end, I am in the Azure portal right now. If I search for Azure OpenAI, I can select the Azure OpenAI service and see that I have access to two services, one located in East US 2 and the other in Sweden Central. Azure OpenAI has a limited access policy, meaning that your Azure subscription would need approval to create an Azure OpenAI service. I'll leave a link to the documentation, which includes a link to the registration form for Azure OpenAI. If you do not have Azure OpenAI, you can absolutely use OpenAI's standard GPT-4 model. But because I do have Azure OpenAI, I'll show off that functionality. Let's drill into the East US 2 service. In order to run this demo, I'm going to need to gather some information and make sure that I have a few things in place. The first thing I need is an endpoint and key combination. To get those, I can navigate to Keys and Endpoint in the Resource Management menu. From there, I have two keys, a location region and an endpoint URL. This is all blurred out to protect the innocent, but I can copy the value of either key 1 or key 2, as well as the endpoint, to a text editor. The next thing I need to do is make sure that I have a GPT-4 deployment available. In the OpenAI service, you simply need the key and endpoint URL. But for Azure OpenAI, you can deploy your own instances of the OpenAI models. Let's select Model Deployments to check that out. Inside the Model Deployment screen, I'll select the Manage Deployments button. It will take me to the Azure OpenAI Studio. This is where things get a little confusing. There is a website called the Azure OpenAI Studio, which is oai.azure.com. There is also the Azure AI Studio, ai.azure.com. The Azure OpenAI Studio webpage is a little older, and the Azure AI Studio is its eventual replacement. I normally hang out in the Azure OpenAI Studio app, but let's select this button to take us to the AI Studio app instead for today's video. We can see that the site looks a little bit different, but I do have a link to deployments in the Shared Resources menu. Inside there, we can see that I have several model deployments, including one for GPT-4, one for GPT-4o, and one for GPT-3.5 Turbo. To create a deployment is simple. I select the Deploy Base Model button. From there, I can select one of the various models available to me. For example, we have GPT-4o, which is a multimodal variant on GPT-4, intended at handling text and image inputs and generating text outputs. But note that as of right now, you can only deploy GPT-4o to certain regions. That's a common thing with Azure OpenAI and is actually why I have something in Sweden Central, because East US 2 and Sweden Central tend to be two regions that get access to services before most others. They seem to serve as test beds for everyone else in that regard. Well, this service is in East US 2, so I can choose GPT-4o and select Confirm. That will take me to a deployment configuration screen where I can set up a few options. I do need to give the deployment a name, and that name can be anything. Then I have a drop-down for the model version. If I select the drop-down, we can see that 2024-05-13 is the only version available to us. The deployment type, I'll leave it at standard. From there, we have a number of tokens per minute that I'm allowed to send. We can see that I have a quota on how many tokens I can push in my account, so each deployment is going to eat into that limit. The scrolling bar tells me how many tokens per minute that I'll allow for this particular deployment. Below that, there is a content filter. I only have a default filter in place, but you can set up your own content filters and use them here. Now, I'll save my rant on content filters for another video and just move on. Finally, the dynamic quota option lets me burst above my rate limit, assuming that I have the quota space available and the server I'm deployed to has sufficient resources. So I can leave that enabled. Now I'm actually going to hit cancel on this because I already have perfectly reasonable GPT-4 and GPT-4o deployments as it is, but I will make note that my GPT-4 deployment is named, characteristically enough, GPT-4. With that information in hand, I can leave Azure AI Studio for now and switch over to Visual Studio Code. Here's the code that we had after the prior video. I could put the Azure OpenAI chat integration on the same page as my visuals, but that might make things a little too crowded. Instead, let's create a new page for those visuals and a separate new page for chat. Doing so is really easy in Streamlit. I can create a pages folder within my source folder. Then I can add any pages I want to it. The index file will be the first page users see when opening the app, but any other pages I have in here will show up in lexicographical order. There's also a neat trick with pages in Streamlit. I can preface the page with a number, and that number won't show up in Streamlit. Let's call the first file 1_review_parking_tickets.py. And the second file will be 2_chat_with_data.py. I have index.py open right now, so I'm going to copy the whole thing and just paste it into the page for reviewing parking tickets. And it's as easy as that. Then we'll go back to index.py. For now, I can replace all of this stuff with a smaller bit of boilerplate. This will give our users a little bit of information and direct them to the correct pages. And because I'm using the pages folder that Streamlit Convention supports, I don't even need to include a list of them in here on the index page. Incidentally, if I did want to customize the layout or not use the default pages convention, I could manually add links to the sidebar, similar to how we added drop-down lists in prior videos. Next, we are going to open up requirements.txt. I will add in one new requirement, OpenAI. This will give us support for the OpenAI API, which Azure OpenAI also uses. Once I've done that, I can install the new requirements. From the command line, I'll give this a run, and it'll take a moment to install. While that's happening, let's open up the Chat with Data Python script. There's nothing in here so far, but we'll fix that quickly with some import statements and the stub of a main function. I did not include a main function on the prior page, though I could easily rewrite the page to support one. In this case, I do have a main function, and that will execute on page load. Right now, I only have a simple header and a basic description, but a couple of lines above the main function definition, I set the page layout to wide, meaning that we will take advantage of all of the screen real estate on larger monitors. By default, Streamlit tries to be mobile friendly. In my case, I care less about how it shows up on a tiny screen and more about how it will show up on my large desktop monitor. Thus, I'll set the layout to wide screen and thereby show less white space on the page. The next thing I'd like to do is introduce the notion of secrets in Streamlit. Secrets are a way of using things like passwords in your code without exposing that information when you check it into source control. If we are eventually going to deploy our application to a public Streamlit workspace, we'll be able to take advantage of some built-in capabilities around secrets management. But even though I'm just building something to run locally, I can still make use of some of the mechanics around secrets handling to protect my Azure OpenAI endpoint and key. What I'm going to do is create a folder called .streamlit in my source folder. Then, inside of there, I'll create a file and name it secrets.toml. TOML, by the way, is short for Tom's Obvious Minimal Language, and this is a case-sensitive file format for configuration files. Let me show you a couple of quick examples. For example, if I want a secret named the answer, whose value, of course, is 42, I can simply include it as a key value pair. I can also denote a set of secrets under a heading like AOAI, standing for Azure OpenAI. Inside there, I could put in my endpoint URL, deployment name, and key. This will provide a logical grouping that I can use in my code. Now, I'm not going to show you the actual values of the secrets here because that would defeat the point. Instead, through the magic of editing, I'll have my secrets saved in that file. Voila. But before I go too much further, I should note that if you're checking this code into source control, you obviously don't want your secrets.toml file in there. Let's open up .gitignore and add one more line to it. That way, we'll leave that secrets file on the local machine, but not check it into the GitHub repo. And using a secret is pretty easy. Let's pop into the chat with data file and plop these in right below the message in the main function. We can reference a secret easily. If it's a regular secret like the answer, we can reference it based on dictionary key or using attribute notation, and I've shown you both of those here. For nested levels like our Azure OpenAI secrets, I'll use dictionary keys to make it easier to understand. Now, let's delete the answer as I won't need it anymore, at least not until I get the question. But I will keep the other references on the page, as I will need them soon enough. Let's now create a couple of other functions that we'll need for interacting with our GPT-4 service. The first function we'll create is called a completion. A completion is the response to our prompt, which I'll describe in a moment. This is the output that our GPT-4 deployment will generate. This function will request a response from our deployment. Let's talk through this. First, we define the function createChatCompletion. It expects to get a deployment name, a set of messages, and an Azure OpenAI endpoint and key. We first instantiate an Azure OpenAI client, and to do that, we need to send in 3 bits of information. First is the base URL, which includes our Azure OpenAI endpoint, as well as the deployment name of our GPT-4 deployment. Next, we are going to send in an API key to show that we are authorized to use this endpoint. Finally, we need to specify an API version. As of right now, the most recent API version is the one you see on screen, though depending on when you're watching the video, that probably has changed. Once we've created the client, we are going to create a chat completion, which is our return statement. We'll pass in the deployment name for the model, as well as a structure format for each message as we want to send it. We'll also request a streaming response so that we don't need to wait for the entire message to return before we see anything on screen. This function is the core of how we interact with Azure OpenAI, and the rest of our code will be supporting code, whose intent is to prepare our requests and display the results. That leads us nicely into the second function we'll create, the prompt. The prompt is the text that we are going to send to the service. It may include information on how the agent should behave, on the thing we want the agent to do or the question we want to ask, and any relevant contextual information the agent may need to fulfill our request. There's a bit going on in this function. Let's start at the top where we get an input called prompt. The first thing we do is append the prompt to our session state. As I've mentioned before, every action in Streamlit results in a postback. Temporary information we've collected along the way won't stick around between postbacks, not unless we store them somewhere. Session state is what we use to store these things. In our case, we're going to use session state to store the entire chat history. That way, when we perform a postback operation, we still have the entirety of history in memory, and we can easily replay it so that users can see more than just the last message they sent and the Azure OpenAI service's response. After storing the user prompt in session state, we write it out as a chat message under the user's guise. Then we have a block that starts with the phrase with st.chatMessage and then assistant in quotation marks. This is where we collect what our chat assistant returns back to us. We'll start with an empty spot as our message placeholder and an empty string as our starting response. Because we're streaming results back, as we call create chat completion, we'll get back a streaming list of responses. We are going to want to handle each one of these response messages, and the way we'll handle them is to add the new content to our full response. Then we'll write out the full response plus a red cursor to indicate that work is still going on. This is what will make our message look like it's streaming in rather than coming in as one solid block. At the end of our for loop, we'll write the full message out without our cursor, indicating that the agent is finished responding. And once the agent has completed its response, we want to save that response in session state to preserve it. There's actually very little more to do here. In the main function, I have just a little bit of prep work. I'll put this in the main function, and its job is to initialize a variable in session state called messages. This will sit above our secrets and below the description. Right below that, I want to display all of the historical messages. This will give us a running tally of everything we've written and received during the session. Finally, we're going to await a chat message. When we get an input from the user, we'll call handle chat prompt, and that's it. So let's see how our app fares. I'm going to first kick it off. Just as before, we'll start in the index file. Now we'll see two additional pages on the left, review parking tickets and chat with data. If I select the review parking tickets page, it will run. Because this is the first time I'm running the page since starting the app, we can see that it takes a little bit of time to cache our results. But once it is done, everything will appear. This page behaves exactly the same as before, so I'm not going to spend any more time on it in this video. Instead, let's go to the chat with data page. We see our simple title and description, as well as a message box indicating that we should insert a message. So let's do that. This gives us back a fairly generic message about what the sign could mean, but one important thing to remember is that our GPT-4 deployment has no idea we're talking about the city of Chicago, Illinois, which has an area called The Loop. Let's ask it again with a little bit more information. Now we get something that's a bit more useful to us. And let's ask another question of it, something that our data set would already have the answer to. And like I said, that's a question that we could easily answer with our data, but as we can see, the GPT-4 model doesn't have an answer for us. That's a limitation that we'll be able to work around, but it'll have to wait until the next video. I hope you enjoyed this video. With just 75 lines of code, we have a simple application that lets us interact with a GPT-4 deployment in Azure OpenAI. In the next video, we're going to extend things a bit and see how we can use our Chicago parking tickets dataset to build out a bit more information for the GPT-4 service and be able to ask it more concrete questions around this data. We'll have links and show notes in the description below. Until we see each other in the next video, take care.